47 if you haven't found it yet, okay? Make sure you follow now, okay? So conditional statements are composed of, they contain these two little words, if, then, okay? And so when it comes to conditional statements, it's the original if-then statement. So we can turn any statement into an if-then, okay? So this is an example here. If today is Wednesday, then yesterday was Tuesday. I think everybody would agree with that statement. And so we break this down into two components. Whatever follows the if is called the hypothesis. We use the letter P for that. And we use a different color for conclusion. Then, whatever follows the then, yesterday was Tuesday, is called the conclusion, Q. Okay? So the logic statement, guys, the notation we use, pay attention to notation. For me to, if I told you P arrow Q, what does the arrow represent? Then. So it's saying if P, then Q. So if I gave you this, you would immediately have to say, oh, this is an if-then statement. That's what it is. Of course, right? So this is what I'm talking about. In order to determine the veracity, so whether or not the verdict is true of the original statement, we dig a little deeper by forming the converse, the inverse, the contrapositive, and the biconditional statements based on the original. And before you panic, I think towards the end, if you do this on your study sheet, you'll be just fine. And if you make some grammatical errors, like if the statement sounds weird, you don't lose any marks as long as the if-then is there. If you have if and then, you're fine, okay? So the converse, have you ever heard of someone saying the converse is also true? Like they give you a statement, they're like, hey, the converse is also true. When the converse of a statement is to flip the hypothesis and the conclusion. Okay, so we're going, it used to be P then Q, you flip it. So what's this gonna say? If Q, then P. What are you talking about? What was Q for me earlier? Yesterday was Tuesday, correct? So you have to say now, if yesterday was Tuesday, what happens? What will follow? What's the arrow? Comma. We're translating this notation, right, on the side here. Then today is Wednesday. So remember, this part was our Q on the original. P comes next. Would you say we flipped it now? If you read this statement, do you think this is still true? Like, can someone say all the time, if yesterday was Tuesday, today is Wednesday? Is there any problem with that statement? It's always going to be true. So in this particular example, the conditional and the converse are both true. Okay? There's nothing wrong with stating that. You'll never find a counterexample to that. Okay? You'll never find an instance where that's not true. So I'm just going to highlight this part in green so you see it, how it flipped. And I'll highlight the hypothesis, our former hypothesis, in orange. You can see that it flipped. Okay? We're always going based on the conditional, the original conditional. Original, conditional, it kind of rhymes, okay? Okay, next. So we did the converse. Now we're going to do the inverse. Inverse. Negate the hypothesis and the conclusion of the original. To negate, we simply add the word not. Okay, so to negate something, we just go not in front of each part. And so this is going to get a little annoying, okay? But I need to prepare you for all three. Every single one of these is saying the same thing. And so not is a bar on top of a letter. It could be this little bracket, like this little L shape, upside down L, I guess, in front, or a squiggly. They're all saying not. So let's just make an agreement. If there's something around in front or on top of a letter, what are you going to think? Not. Okay? All right. So if your parents want you to clean your room, they text you, you just text one of these back. Like I don't know if it's possible, but just put a bar on top of it, right? Like, yes, bar, right? Yes, I'll do it, bar. That means you're not going to do it. They won't find out, right? See, you learn important things in school. So we go back to the original. Let's take the original where my finger is right now and negate that. If today is not Wednesday, I'm going to shorten Wednesday, okay? I believe that even on the provincial exam, you'll be okay with that. Maybe don't try it on the exam, okay? Don't try it on the exam. Then, yesterday was not Tuesday. And again, this part right here, because of the not, you can say that this part is not P and this is not Q. Oh, you can't see that. Sorry, guys. I'm trying to have the original on the screen as well. But if today is not. So all you have to do is you take the original and you just insert nots on both parts. Okay? Contrapositive. Contrapositive is flip and then negate the original statement. Listen carefully. Flip, by that I mean we're taking, there used to be the P here, now it's Q there, right? So we flipped them, and what else did we do? We negate it. So it's like a mix of what happened before. So be careful. So we're going to say this. If, what do I start with? Q, right? And I need to negate it. Where am I going to look at Q? Which Q am I looking at, Mr. Dirksen? You go back to that one. Look at my awesome camera work, right? That's Q right now. So we're going to have that first, and we're going to negate it. That's how we're going to start. If yesterday was not Tuesday, then, so we're supposed to take P now and negate it. Then today is not Wednesday. So this part right here is not Q, and this one right here is not P. And of course, the then always is always the arrow, right, pointing from Q to P. And I'm not highlighting these because they're knots, so I don't want you to mix that up, right? You actually have to negate it. So I'm not highlighting that. And last but not least is your biconditional. Biconditional, we substitute if and only if. So if the province says, grade 12 applied students are really happy when there's no test, right? That's the statement the province says. And it's like, write the biconditional of this statement. You would say, grade 12 applied students are happy if and only if there's no test. You know what I mean? You just insert the if and only if. So based on our conditional original, what would we do with this one? With this original conditional? How would we make this a biconditional? You get rid of the if and the then. Okay, you just focus on P and Q. So we would say today is Wednesday, if and only if yesterday was Tuesday. That's all you need to do. Get rid of the if and then, and just insert if and only if. Okay, so we'll say this. And this is the notation, guys. Make sure you get your notation. What do you notice about the arrow? It goes both ways, right? Before it was always going one way, now it's going both ways. So we would say this. Today is Wednesday if and only if yesterday was Tuesday. This is the important part. There are no counterexamples. What is a counterexample? A counterexample is an example that proves that statement wrong. If you can think of just one counterexample, it proves this statement wrong. So technically you can't say this if there's a counterexample. Okay? We'll talk more about counterexamples later. You know what? I'm going to add this because we're already here. One example proving a statement wrong. I'm going to give this a color that I haven't used yet. An example proving a statement wrong. Give me an example. I'm making up silly examples. If your last name starts with a D, you're 6'5". Is that statement always true? No. So I'm 6'5", my last name starts with a D. Is there a counterexample in this building? Is there someone that has a last name that starts with a D that is not 6'5"? I actually can't think right now, but Mr. DeGrave. You know how I know he's not 6'5"? I always have to look down on Mr. Don't tell him. Oops, it's recorded. We're good friends. We'll be fine. We'll get over this. Okay? Yeah. Okay, so here's your summary. This is summarizing everything. I would like you to, at some point, add this to your study sheet. So I'm going to highlight the whole thing. Some students are extremely resourceful, and they actually somehow manage to squeeze in an example of each. I don't know how they do it, but they are able to do it. I'll show you some study sheets towards the end. But if P then Q, you're supposed to go by that. Okay? Converse is if Q then P. Inverse is if not, then not. Contrapositive, if not Q, then not P. Biconditional, P if and only if Q. Okay, add to study sheet. And I need you to know something else on this table right here. that the conditional statement, this one right here, and the contrapositive, make sure you make that connection. I will just say equivalent. I'm going to write that on the side here. If you just want to go equal, I'm okay with that. But the conditional and the contrapositive, it turns out that you're saying the exact same thing. You're just saying it differently. The converse and the inverse are also equivalent. So in case the province ever asks you, right, write the converse, and then asks you, write a statement that would be equivalent, logically equivalent to this one that you just wrote, you should know that the inverse would be logically equivalent to the converse, and that the original conditional is logically equivalent to the contrapositive. Okay? Yikes, right? So I'm going to give you a little bit of time to practice this. So I want you to try 1 and 2 here. You got it? Can I move on? Maybe I need to start it with you. Yeah, so the statement says if Sandra cleans her room, then Sandra's mom will not get upset. This is the conditional statement. This is basically if P, then Q. That is given to you here. How do you know which one is P and which one is Q, Mr. Dirksen? Whatever follows the if is our P, and whatever follows the then is our Q. Got it? So P, then Q. Symbolically on the side, we identified which one is which. I should have mixed these up on you, but it's okay. If you have your study sheet filled out, you'll be fine. What is the converse asking for? Check your study sheet. It's asking for if Q, then P. So what are we going to start this statement with? If Sandra's mom will not get upset, then it's a one marker. These questions are one markers. They're easy marks if you know what you're doing. So if Sandra's mom will not get upset, we start our statement with the Q. Then, what is P now? Then Sandra cleans her room. That's it. The inverse. What is the inverse asking for? Go check your study sheet. And what the inverse is calling for is not P. If not P, then not Q. So you basically leave the order as is. You just have to put a not somewhere. If Sandra doesn't work, does not, yes, it's fine. If Sandra does not clean her room, does not, right? That's the key there. Then Sandra's mom will not get upset. How do we deal with something like that? How do you negate this one? Sandra's mom will not get upset? Technically, you're okay with that. What does it mean if you say not? That you're actually It's actually going to happen. She will get upset. Okay? So it's up to you. Then Sandra's mom will get upset. I had to throw that in because not translates to will get upset. Mr. Dirksen, what if I wrote not? It's almost like a knock-knock joke, right? So you can do that if you want. It's okay. So I'm going to leave the rest to you. Practice the skills for a few minutes because I do have a little bit more yet. So practice that. I will have the answer key up front here in a bit. If you're not sure, I can help you out. But make sure you fill in this page at least. There's more on the back side. Okay? Show you. So, for example, if you finish the example, Sandra's example, contrapositive is negating Q and P. So it's if Sandra's mom does not get upset, then Sandra does not clean her room. Does get upset, sorry, I should say does get upset because it's not, and then it is actually you do get upset. But if you wrote not is okay. Biconditional, Sandra cleans her room if and only if mom does not get upset. Okay? Next we have Caleb, and I'll post the key to the back of this if you need to have a bit more practice. What's the converse? If Caleb gets 100%, so this part comes first, then he attends every math class. Okay? If Caleb does not attend every math class, that's the inverse, right? Does not attend every math class, he will not get 100%. Contrapositive is flipping the inverse in a sense. If Caleb does not get 100%, right? Caleb does not get 100% in math, then he will not attend every math class. And biconditional, Caleb attends every math class if and only if he gets 100% in math. Okay? Okay. Let's keep going. Let's go to 50. Checking for the veracity, whether or not a statement is true. Just because something is phrased as an if-then statement does not make it true. For example, if an animal is a bird, then it can fly. Before we continue even, is this statement always true, or is there even one counterexample? Penguin is a bird, cannot fly. So it's actually a counterexample to this scenario here. So technically the statement is false. It's just false because it's just not always true, so it ceases to be something we would consider a true statement, okay? A statement is false if the hypothesis is true, but the conclusion is false, okay? Basically, I'll tell you this. If you have P then Q, okay? If this is the case, you find that this first part is true, but the second part is false, it turns out that the entire statement is just a false statement. This is going to help you a lot later on, that understanding, okay? Here it is again. A counterexample. To prove that a statement is false, we need a counterexample. A counterexample is an example where the hypothesis is true and the conclusion is false. Some examples here, right? Ostrich is a counterexample. It is a bird, but it cannot fly. So let's make sure you understand this. P, that part is bird, right? It fits the criteria. Ostrich would be considered a bird. but Q, right, can fly. Can a ostrich fly? Right? So you've made sure that the first part is true. You've met the condition of a bird, but the second part is false. Therefore, it's false in general. So this is a good counterexample. Ostrich would be a counterexample. Penguin would be a counterexample. There's more, right? But in this case, that's what you want. And look at this statement here. There are no number of positive examples that can prove that a statement is true. You can have 1,000 examples. No, look at Mr. Erickson. There's these thousands of birds that are birds and can fly. But if you find one counterexample, it is enough to prove that statement false. It's right? It's interesting, right? You can say, like, I never lie. Never in my life have I lied. Look at these thousands of examples where I've never lied. But if you've lied even once, you're technically now a liar. Right? It hurts, but you are, right? Like, you've lied. Okay? Anyways, consider the following statement. If a number is prime, then it is odd. This is your statement. This is your prime number set, by the way. Is this a true statement?
No.
Is it true? How do you know? If not, give a counterexample. Example 2. That's your counterexample. And then explain. It is prime. It is prime. So P is true, correct? But it is not odd. Q is not fulfilled. So counterexample is 2. 2 is the exception. It's the reason you cannot say this ever. You're lying if you're saying this, right? You can't say prime number is odd. You can't say that. Okay? Let's you can try here. If a number is even, then it is divisible by 4. Is that counterexample? 0, 2, right? Example 0, right? 0 is even, but not divisible by 4. Okay, and there's 2, right? 2 is even. 6 would be even, can't be divided by 4 evenly. Okay? So, counterexample. If today is the last day of classes this week, then tomorrow is Saturday. This is always true. False, right? Example, a week where the last day of classes is on a Thursday. Right? Maybe Friday there's an in-service. So tomorrow is not Saturday for you if today's the last day of class, right? If Friday had been an in-service. So if you live in Winnipeg, then you live in Manitoba. Is that always true? Yeah. If you live, how about this one? If I live in Manitoba, then I live in Winnipeg. No, not always true, right? You can, it's like example, Winkler. You live in Manitoba, you don't live in Winnipeg, right? So that's so this is true. Always. Sorry. Always. No counterexample. I know this is dry, I know. I should do a dance one of these days to make this fun. Anyways, you would never forget that, let's put it that way. Okay, one more thing, guys. If there's no counterexample, then we can state, no, sorry. I take it back. I'm not 100% sure, so I'm not going to say that. but no counterexample, it is always true. That statement is always true. Let's keep going. Ooh, truth tables. I'm going to stop here and start a new video.